Hi there, my name is Turk, and today I'll be telling you about my experiment I performed, which was the synthesis of isopentyl acetate, also commonly known as banana oil. Esters are conveniently synthesized from carboxylic acid and alcohol, with the presence of an acid catalyst. When performing a procedure, it is very important to perform all parts of this procedure to obtain the results intended. Isopentyl acetate is synthesized with an equilibrium reaction. How I synthesized it was with a microwave reactor. And then the solution I got when it was synthesized, I took that and put it in HNMR to obtain data to confirm that isopentyl acetate was indeed produced. How a microwave reactor works is you place it in the microwave reactor, you set a specific temperature and time period that you want your sample to heat up to, and for how long you want it to heat up to. After that time period has elapsed of your sample heating up at that temperature, it allows it to cool down to another specific temperature that you set in through a computer, and then your sample is ready to be analyzed. And why a microwave reactor is a preferred method to use is because it heats the sample from inside to out, which saves time and energy. And why we will be using HNMR is to help us determine that we produce isopentyl acetate. How it will do that is from the data it produces, because HNMR tells us 4 things about a molecule. It tells us 1, how many different types of hydrogens we have. 2, what those hydrogens are next to as an electronegative elements, which will move their peaks downfield. 3, the splitting of those hydrogens, so how close hydrogens are next to each other. And then 4th, the integration of hydrogen, which means how many hydrogens are in each peak. And how an HNMR works is it uses a magnet to line all the protons of the molecule up, and then it hits it with radio waves to knock those protons out of alignment, and as they come back up in their reading, it gives us a graph of the data, because all the different types of H's will come up at different frequencies. Alright, so what I did in my reaction, I took 4 milliliters of acetic acid, 2.8 milliliters of isopentyl alcohol, 20 drops of sulfuric acid, which was, as I said before, an acidic catalyst, and then 2 grams of silica beads to help remove all the water at the end of the reaction, because when our isopentyl acetate is produced, it also produces water from the equilibrium reaction. So the silica beads will help to soak up the remaining water from our solution. So then I placed my sample in the microwave reactor, and I heated it to 130 degrees for 15 minutes. Then after those 15 minutes had elapsed, I cooled it down to 50 degrees Celsius. And once that was done, I took my sample and ran it through the HNMR to see if I had in fact produced isopentyl acetate. Alright, so from my graphs, it showed that I had 5 different peaks, which means I had 5 different types of hydrogens. The first peak was integrated for 6 hydrogens. That means it had 6 hydrogens that were all the same, and that was a doublet, meaning that those 6 hydrogens were very close, were 3 bonds away from 1 hydrogen. The next peak I had on my graph was integrated for 3 hydrogens, and at first when I looked at this, I was a little confused because there was nowhere where those 3 hydrogens could be, but there's 2 hydrogens and 1 hydrogen that were awfully similar to each other, and that's why I gave the peak of 3. And that's considered a multiplet because it was talking to the 6 hydrogens from the first peak and 2 other hydrogens, making it a multiplet. So the third peak I had was also integrated for 6 hydrogens, which when I first looked at this, I could tell that something went wrong with my data, because it should have been integrated for 3 hydrogens. And that was a singlet, meaning that it wasn't close to any other hydrogens. So my fourth peak on my graph was integrated for 2 hydrogens, and that was a triplet, meaning that it was talking to 2 other hydrogens, which I saw from the structure of my molecule. And the last and final peak that I saw was integrated for 1 hydrogen, and this was extremely downfield, in around 8 ppm, parts per million. And what this told me was that there was an OH left in my sample, which could not have happened because isopentyl acetate has no OH group in it, which led me to believe that there was presence of acetic acid left in our sample, so it was not removed. So what went wrong in my procedure was I missed the part in the procedure where I was supposed to wash my solution with a 10% sodium bicarbonate, which would help to neutralize the rest of the acetic acid and remove it from the sample. Alright, so now in conclusion, I found that I did indeed produce the isopentyl acetate because I saw all the correct peaks for that, but I skipped a step in removing the acetic acid, which is why I found the mishaps in my data. And missing a step in a procedure can alter your results, but those results are not useless. Determining your mistake from these results is essential in becoming a better chemist. Thank you. Any questions?